Hello, good evening. This is Sax. Good day. The first question being asked by the recruiter is, can you please walk in through your resume? The answer is yes, let's both walk in through. What's my objective? It is to experience the challenge of core Java, C, C++, C#, MATLAB, Python, Prolog, Octave, R, with OpenStack, Hadoop, AIX, JTE, embedded systems, drivers, artificial intelligence, clouds, clusters, distributed computing, virtualization, machine learning, graphic user interfaces using 3D games, either in isolation or in combination using Waterfall, Agile, Scrum, as a big data scientist or an architect or a development team lead or a program manager or into research and product development within a business or a corporate environment to utilize in combination all of my strengths and tools mentioned as follows to strengthen the business or its clients' competitive as well as strategic position, consequential of my career-wise positioning fortify as well. Right, let's speak of my strengths now. I have a strong commercial inclination, project management skills right from bid estimation, implementation and risk management. I'm very dexterous in stakeholder communications and negotiations. Very strong in the relevant frameworks, design patterns, data structures, APIs and interfaces, libraries. I can use them in isolation or in a combination too. I've got an exceptional problem solving, solutioning and system designing and technical architecturing skill, along with a strong ability to grasp any domain knowledge of extreme complexity, either it be in a business, governance, judiciary, politics, scientific, machine learning, artificial intelligence, or let it be of higher order logic. Using mathematical and statistical reason, I can solve problems right from concept to concrete implementation. I've got a strong potential to execute projects right from RFP, POC to the architectural designing to infrastructure and capacity planning, down to development, refactoring, reusability codes, testing, debugging, building, integrating, deploying, and maintenance. This I achieve through a strong wide network of professionals and doctorates from various scientific disciplines who assist me either in a paid or an unpaid consultation during any phase of project execution. Alright now, let me speak a little bit about the key projects that I've done through my career. Starting from a knowledge engine, which is a platform as a service, delivered through a private cloud. It's an OpenStack SX in CentOS, it's a private cloud service, which is a platform as a service, which we further look forward to extend as everything as a service, which is load balanced using Atlas, and also sort a single tier of persistence using Cassandra, which offers a custom image via KVM glance. The image is a CentOS 5.7 again with a JTE container service offered by JBoss, along with a rules engine to access facts from where I'll tell you later, okay? Now, who are the clients that are gonna use the private cloud? Those are clients from banking, education, research, capital markets, and retail chains. What they're gonna do, they're gonna deploy the enterprise application into this JBoss container. For what? To avail of the decision rules service that will be offered from the backend infrastructure that I'll be speaking to you shortly. Okay? Now how do they get it? They get it through active subscription into the messaging ActiveMQQ using JMS from the JBoss application. Believe me, if someone hasn't designed and developed their JTE applications according to the JTE specification and also EJB3 specification, This service is not for them. Alright, now let's go to the back end. What do we have today? It's a tri-layered architecture with an information extractor, an accumulator, a model builder, and a knowledge builder. Let's see how it starts. On the front end, we've got a Memcache nut crawler which retrieves information from the World Wide Web into from restricted domains, which is further vector spaced and indexed using Solar Illusion, which is again cached into the MongoDB. So what we have in MongoDB is our key value pairs of keywords and pairs of URLs. Now, we're gonna MapReduce what we've got as URLs as retrieving the information, let it be of media and textual by nature, and allowed for filtering using MapReduce, and this will be stored into the cluster. The clusters of it is a HDFS cluster of 21 racks and 420 nodes. Now let's speak a little bit about the physical infrastructure. What we've got here is a IBM System X X3750M4 server. That's what I said, into the 21 racks, which forms the 420 cluster with an operating system of CentOS 5.7 again. If you look into the combined capacity, the processing power of 4004 GHz, a DIMM of 16.1 terabyte and storage of 6.7 petabyte, and a throughput of 4,200 GB per second if it's combinatorial, or 10 GB per second if it's linear otherwise. Now from this HDFS cluster, we allow for MapReduce job to build models and schemas into the HBase of the Hive. Structure as declaratives and spatial transformation, and all of these same MapReduce jobs, to put it in general, does make a lot of API calls into Obio, Nyquist, CLIFS, Julius, and MATLAB for the purpose of speech-to-text processing of audio files, and for the purpose of NLP. When I say NLP, it's natural language processing, model building, using MapReduce in the database structuring again into HBase, using unsupervised learning of clustering, principal component analysis, and factor analysis using Pig and Mahout. And again, it goes back into both HBase and the Hive database structure. Now what do you do with the image and audio files? We need to build a spatial knowledge building. How it's done? It's done through MapReduce API calls to OpenMax and OpenCV, which rips apart these files and, retrieves information. Again, whatever is retrieved is transformed spatial using AutoCAD, and that's stored specifically to the Fanus graph data structure in the HBase. And all that we have in HBase and Hive, what do we have this for? It is for the Prolog engine, that's a knowledge building engine, to access and generation of facts and decision rules and hypotheses and theorems and rules proving and checking for consistencies and inconsistencies, and whatever is built is stored in the hypergraph. And as it is stored, it's also published into the active MQ, into separate queues. I can see there are quite thousands and hundreds of thousands of queues that we had in place for that. As a client using the private cloud, their application, as I said, they're subscribed to this ActiveMQ queues, and they receive messages which are nothing but facts and decision rules, which would further be injected into the decision rules engine, into the JBoss container for the JTE application, so that they don't have to manually write down the rules which they have been doing previously. So entirely, a lot of redundant tasks, redundant mental tasks have been eradicated through the service that we offer for the clients, and the clients are greatly benefited due to accuracy and reduction of costs, and gain of high availability. Believe me, it would take a long time for me to explain all this in detail, probably later.